In this question, we have to write the structures of monomers used to obtain the given polymers. First one is neoprene. This is a synthetic rubber and also known as polychloroprene. This is made by the polymerization of 2-chlorobutadiene. They are resistant to oil, heat and weathering. It has a good chemical stability, flexibility and durability. The second one is PHBV. This is poly 3-hydroxybutyrate 3-hydroxyvalerate. This is a type of biodegradable polyester and it is a copolymer of two monomers, that is 3-hydroxybutyrate and 3-hydroxyvalerate. They are thermoplastics and environmentally friendly. It is less flexible than some other bioplastics and it is also used in packaging, medical applications and agricultural films due to its biodegradability. The third one is given as bakelite. This is a thermosetting polymer and this is the first synthetic plastic. This is made by the condensation reaction of phenol with formaldehyde. They are hard, heat resistant and electrically non-conductive. It is brittle but durable under heat and chemical stress. It is used in electrical insulators, radio and telephone castings. And it is also used in various household items because of its heat resistance and electrical insulating properties. Let's come to the old question. We need to arrange the given polymers in decreasing order of their intermolecular forces. And the polymers are bakelite, polythene, Buna S and nylon 66. Among these four, the strongest type of intermolecular interaction is present in nylon 66 and the least strong one is present in Buna S. So we can arrange them as nylon 66 greater than bakelite, which is greater than polythene, and the less one is for Buna S. The other question is to write the monomers of the given polymer. By using the structure of the given polymer, we can find out the monomers used here. They are ethylene glycol and phthalic acid. In the next one, we need to write the structural difference between high density polyethylene and low density polyethylene. This HDPE and LDPE differ in the structure based on the molecular arrangement and branching patterns. The HDPE has a linear molecular structure with minimal branching. This allows the polymer chains to pack closely together and result in a dense crystalline structure. Their density is higher due to the tightly packed chains and this is more rigid and it has a higher tensile strength and is more resistant to impact and chemicals. It also has a higher melting point. Coming to the LDPE, which has a highly branched molecular structure and the branches prevent the polymer chains from packing closely together. It will lead to a less dense amorphous structure. They have lower density because the chains are less tightly packed. The property can be explained as they are more flexible and it has a lower tensile strength and is less crystalline. It has a lower melting point and is more transparent and pliable. So we can say HDPE has a linear structure with little branching, making it dense and strong, whereas LDPE has a more branched structure, making it lighter and more flexible.